volume of solids of revolution. And here we have two methods, the disk method and the washer method. First, let's understand what is the disk method. So let's say we have a curve y equals x squared. So we will draw it, okay? And it is bounded by the line, by the vertical line, x equals to 2. So draw this line. So this line will be this. It's going to be a vertical line. Okay. So first, you have to identify the region between these two curves, y equals x squared and x equals to 2. So shade that region. That region is going to be this. And x equals to 2 is this straight line. So the region between these two guys is this, the one that I'm shading with yellow color. Get rid of everything else. So get rid of this line, get rid of this curve, and get rid of this line. Now what they will say in the question, so they'll give you the curve. So you draw the curve, and then they will say that we have to revolve this region. Now you have this region. We are revolving this region about x-axis. So when you revolve this region about x-axis, you will get a solid, and you have to find out the volume of that solid. So you know what shape you will get?
What? What shape?
So if you're revolving this region like this, about x-axis, this is the solid that you will get. I hope you can imagine this. It will look sort of like a witch's hat. Have you seen a witch's hat?
Yeah.
Yeah, so just... It is not a cone, but it is kind of like a funnel like this. Right? So this is the solid that you will get. And there will be a circle at the base, sort of a circle. I hope you can visualize that as well. Right? This is a... Like if you've seen Harry Potter, then the sorting hat. Okay. So that's the solid. Now we want to find out the volume of this solid. Okay, this is called solid of revolution. Okay, Tanvi, so how do we find out the volume of this solid? What we will do is we will slice this cone. Imagine that I have a knife and I am slicing this cone at any point. Okay, so you see this? This is, I have created a cross section like this. So first of all, what will this cross section look like? Now you have two pieces. You have sliced off this cone. So you have two pieces. So if you look at the middle, what does this cross section look like?
I don't know.
No, you have to just imagine if you have a cone.
The cross section.
You slice it from the middle. Yeah, so you have two pieces. Right? You have two pieces. You're looking from here. What do you see? What will you see? The cross section.
Yeah.
What shape? A circle, exactly. So you'll see a circle. Okay, I'll show it to you. Cross section of a cone. See, like this one. If you slice it, if you slice a cone parallel to the base, you will see a circle. That's what we will do in all the questions. We will slice the solid and you will get a circular cross section. Okay. So in order to find out the volume of the solid, what do? We will find out the area of this circular cross section. So you'll have a circular cross section here. You will find out area of this circle, area. Now, you know what is the area of a circle? Pi r squared, right? Now we want to find out the radius. So radius will be this.
Okay.
Can you find out the length of the radius? you know that this function is y equals to x squared. So can you tell me what will be the length of this radius from this point to this point? We did this in last class as well.
Yeah. So you just calculate the distance. So to do that, you set them. You set you create an equation for the line set equal to the
See,
x squared.
what will be the y coordinate of this point? This point.
That's the intersection between the line and the y equals x squared.
Yeah, this point is just, so whatever is this point, it will be x comma x square, because this
Mhm.
curve is y equals x square,
Yeah.
right? Y coordinate will be x square, and this point is just 0. So this vertical distance will be just x square, just the y coordinate of this point,
Mhm.
right? So your radius is x squared. So your radius will be always the function, whatever is the given function, let's call it y equals f of x. This is, right now I've taken x squared. This could be anything. This could be any random curve in the world. So your radius will be f of x. Okay.
Mhm.
And so your area will be pi times f of x. See, r square, so f of x square. Okay.
Mhm.
And that's just the area of one cross section. Just like this, you can draw multiple cross sections. And to find out the volume, you just have to add the areas of all the cross sections. You'll have multiple cross sections. You have to add all the areas. And for that, you will just integrate it from this point to this point. So from 0 to 2. This point is 2 because this
Mhm.
line is x equals to 2, right? So from 0 to 2, you will add all the areas. So pi times f of x square, pi r squared, and dx.
Mhm.
So 0 to 2 pi, f of x is x square, function is x square, so x square square dx. This will be the volume of this solid. Okay?
Yeah.
And that's your disk method.
Okay.
Okay. Now, one more thing is, in this question, we revolved the region around the x-axis. Now, you can also have questions in which you are revolving around the y-axis. See, if you revolve it around y-axis, it will be like this. Around x-axis, it is like this. So
Mhm.
if you do it around y-axis, then what will happen? Things will change. So this is the function x square, okay? And this time, the question will be also different. Now you will have a line y equals to 2. So the line y equals to 2 will be a horizontal line. This is the line y equals to 2. So your region is, shade the region first. This is the region.
Mhm.
Now get rid of everything else. Get rid of everything else. And now you're revolving it around the y-axis. So it will revolve like this. This is your y-axis. So this time what shape you will get? In order to draw the solid, just draw the mirror image. Okay, so just draw the mirror image
Mhm.
around the y-axis this time.
Okay.
Okay, so this is the solid that you will get this time, which is kind of a hemisphere. Not exactly hemisphere, because a parabola is like this, not exactly a hemisphere, but kind of like a hemisphere. So this is the solid that you will get.
Mhm.
Okay.
Okay.
Now, in order to find out its volume, again, we will do the same thing. We will take a cross section. This time our cross section will be like this.
Mhm.
Okay. Again, what will be the radius of this cross section? This will be the radius.
Mhm.
Okay. And this time, what we will have to do is everything will happen with respect to y. We will write this equation of the curve with respect to y. So right now, our function is with respect to x, f of x. You will write the function with respect to y. So x is equal to f of y. Okay, so you need to change it with respect to y. So y is equal to x squared. Now solve it for x. So x
Mhm.
will be equal to plus or minus square root of y. Okay, so the right side is positive square root of y and the left curve is negative square root of y. Okay, so this is your
Mhm.
curve, x equals to square root of y. Okay, so what we will do, this is the x coordinate. Any point on this curve will be of this point. X coordinate will be square root of y, comma y. Any point. Okay, so the radius will be, this is the radius. Radius will be, length of the radius will be square root of y. I hope
Mhm.
you are understanding this.
Yeah.
And that's it. Now, area will be pi r square. This is r. Pi times r is square root of y. So square root of y squared, which is pi times y, because square root of y squared, that's y. And now, just like this, we will have many, many, many cross sections.
Mhm.
These are all the cross sections.
Mhm.
So we will add the areas of all the cross sections from this point all the way up to this point. So this time, your integral will be 0 to this point. This point is again 2. Area is this pi times y. And this time it will be dy and not dx, but dy.
dy. Okay.
Okay. So this is
Mhm.
your disk method. Why is it called disk method? Because this cross section we are taking, this cross section is actually a disk. It has a very small height. You know how a disk look like? Circle, and it is
Yeah.
very small height, like very small height. So that small height is actually this dy or dx. So we are finding out the volume of that disk. And then we're finding out volume of all the disks and adding all those volumes, or consider it area of a cross section. Okay,